catastrophic. Oh.
So toy crouch.
For the record, that was supposed to go to you, but it didn't work.
Don't put that in a video.
This is why we don't do these things in public.
Okay, keep in mind this is not a final design, we're just going through some basic stuff. Okay, now, so we have kind of the principles of a robot now. We're going to go through some of these designs or ideas people had for mechanisms that do what we want to do. And we're going to decide whether it's logical or if it's even possible. And we're going to decide kind of what we want to basically want to accomplish. Like, do we want to collect discs from the CD player and shoot them? Do we want to pick up discs off the ground and dump them? Or do we want to pick up discs off the ground and shoot them? What do you think will be the easiest to do, and what do you want?
And then there's the issue of, like, if the disc is upside down or right side.
Yeah, exactly. The only way we can shoot discs is if they're the right way, because that's how they get their lift. If it's the other way, they'll just fall to the ground and eat forward. So, okay. Yeah.
Well, let me counter that. The problem is, you're going to be handing the disc to them. You have to go all the way to the other side. If it's not quick enough, you're a 125-pound robot. You're not quick enough to go from there to there multiple times.
Right.
Shooting that or putting it in the
Also, we have already decided that we're going to be maneuverable, quick, and simple. So, being a fast robot that is very maneuverable is really easy to get from the other side of the boat. I swear to you, these robots can be fast. Like, it's not, the field is not as big as you think. It's big, but it's not as big compared to the robots. Like, it's a good argument, but it's not really.
So, actually, yeah, an idea might be to have a plate of metal on the front that the pistons would just push out, which they got to function as a ramp.
Or an elevator ramp. I don't know if you guys saw that video. Well, I think somebody posted on Robotics
How
last
did you
year.
vote?
This robot, it was like
Really cool, man.
It was
an elevator probably.
okay. Elevators are cool. It's on the list.
You're on the list. Putting it
And where's our work? Alright.
So like the robot last year, like it would get the ball and then would like go up like this and shoot it, and then it would be a ramp for everybody else to get on the bridge, and then it would cling to the side of the bridge and triple balance.
And now, we're going to go through each one of these strategies and go through pros and cons of each strategy so we can kind of decide as a team what we want to do overall, whether we want to be strictly defense or strictly offense.
So, you can have pretty much free run of the place, but be respectful, don't mess things up, put stuff back where you got it from, all of that kind of good grown-up-y type things. You guys were fantastic last year. When you left, we couldn't even tell you were here. Actually, we could, because most days you left it cleaner than you found it. So, I really appreciated that, and if you guys can keep doing that this year, you can have the space again next year and the year after that, and so on and so on. So, you know, it was a lot of fun last year for me to be involved in it. I'm happy to do it. So, I'd like you guys to just keep doing the same thing that you did last year, and it'll be great. So there's probably a bunch of people who are in science and engineering and things like that. So how many of you are science type folks? And how, let me see, show hands. And how about engineering types? All right, so kind of the same bunch. So a lot of what we do here is engineering work and design work. And so we do a lot of CAD work, and we do a lot of computer modeling, and we build prototypes, and we test things, and we just do a lot of things, and we figure out the best way to do them. And everything is different, and everything is new. And so we've worked on a lot of different projects and a lot of different product categories. Most of what we do now is off-road vehicle stuff, but in the past we have done a lot of various different things, and we still do some various different things, but one of the cooler things that we did was this pogo stick, and it is basically an infinitely adjustable pogo stick that generates 1,000 pounds of thrust and 7 Gs of force, and can get an athletic rider 12 feet off the ground. And guys ride things like this in Boom Boom Huck Jam and X Games. It's been an exhibition event, and guys can bust out backflips on these things and just go down the street, backflip after backflip after backflip.
Yo, I'm swagging on my swagger, and my swag got swagger. Swiggy diggy dagger and a sniggy snagger. Cause my car is swagger and it has a lot of dials. And the dudes be jelly cause my car is really fast. Call me Bruce Wayne cause I'm fly like the Avengers. Call me Fred Flintstone cause I yabba dabba YOLO. Call me Vegeta cause my swag over 9,000. They call me Corey cause you don't want to peck a dog. Swagger.
This was actually one of the most difficult engineering problems that we had to solve. So hold on to that for a minute, just like that. So this is the guts of the thing, and essentially this is in here like this. And so each one of these things is a really high-tech rubber band that generates about 100 pounds of thrust when it's engaged, and there's 12 of them. So 12 times 100 is 1,200 pounds. You lose about 20% in driveline efficiency, so you lose about 200 pounds of thrust just from the friction of the whole mechanism. And they can all be engaged and disengaged individually, and you can adjust the length of the piston, and there's nothing else that's like it. It's the only thing of its kind. And so figuring out how to make a pogo stick, our client came to us and had a patent on this technology and said, we can't figure out how to apply the patent in a commercially acceptable way that's manufacturable and works and is safe and all these things. So that's why they came to us. And so we did it for them, and we got it to work. And so it is the most ridiculous pogo stick that the world has ever seen. This is the design studio. And so all of these desks are where engineers and designers will sit. And it's got this big, massive open space and these big doors so that we can take vehicles through the doors and have vehicles right in here. So when guys are working on things, they can have a vehicle parked right in front of them so they don't have to get up and walk around and go really far to get to what it is they're working on.
But right now, these are the least important part. That'll be relatively
Maybe, I don't
simple
know
to
if
figure
it'll
out.
matter. I think it'll just shoot
It's
out.
getting this to work the way that we want it to.
I mean,
Because to me,
maybe
the
it's
hardest
just
part
go for
is
it.
having this
Yeah.
hook
Yeah.
actually staying where it is.
Actually, that's my
We need to make the gearbox. We need to get a gearbox that speeds it up like crazy.
Yeah.
That's going to be the
Let's
hardest.
Look up that one. So they definitely know what they're talking about.
We're prototyping, and it's a prototype of a prototype. Don't even joke. It works good as a dumper.
Next, that's gotta be it. Don't wind up dead.
I'm fine. I'm good. I gotta shoot it. Wait, I gotta do left arm now.
It's probably gonna be a couple of seconds here. I gotta read down.
Wild goggles appear.
Bum 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 bum. Alright, are you ready? Yeah. We've been ready.
I'm really liking the dumper idea.
Hey, this works as a dumper too.
That's right.
Yeah.
That's right. High-tech dumper.
Hey, do it again, Harold.
Could he possibly get more power?
Yeah, push it harder.
Consistent results.
Well, it does work. That's the result. That's what we're looking for. Being okay at something is the first step of being really good at something. You wouldn't slam it. You like, basically, you want a game of pinball. You just go. And it just flies.
See, I don't know how to make it. You just have to figure out how to make it really fast.